Hello everyone, welcome to Sec 325. Thanks for taking time to attend today's session on event-driven data security using Amazon Macie. I am Neha Joshi. I am a senior technical account manager with AWS and I'm based out of Sunnyvale, California. This is a 300 level talk, so I'm gonna go over a mixture of deep technical concepts as well as some of the higher level things that you can get benefited from. So, my goal for next 30 minutes is to cover sensitive data discovery mechanism and how the event-driven approach can help you to leverage a secure, cost-optimized, and automated solution to protect your data in AWS. So the way I'm going to be stepping through this is by first going over Amazon Macie key features and then sensitive data discovery mechanism. I'll also be discussing what the event-driven approach is all about by diving into its workflow, architecture, and configuration details. Then, I do have a demo to walk you through the solution, after which I'll also be discussing the best practices that can help you to get started with Macie. So let's jump right in. The first interesting thing to start off today's discussion, which most of you might also be interested in knowing, is what's new with Amazon Macie and what has changed from Macie Classic. So, last year in May 2020, we launched a completely redesigned Amazon Macie. It's a fully managed service that uses machine learning to help you discover and protect your sensitive data. If you're one of the existing Macie Classic customers, then you can continue using that, but we do encourage our customers to transition to new Amazon Macie to leverage some of its enhanced capabilities, which are significant price reduction that lowers the price from 80 to about 90% with the volume discounting tiers, and that mainly comes from re-architecting Macie's data discovery and deeply integrating with Amazon S3 to perform even faster and more scalable data detections. In addition to that, the new enhancements include the updated machine learning models to perform more accurate sensitive data identifications and also support for the custom data identifiers for your proprietary data. With just one-click enablement, you do get the access to S3 inventory data, and also you can leverage the redesigned Macie console as well as its APIs. Werner Vogels, AWS VP and CTO, comments that protecting your customers should be your number one priority, and without that, you don't have a business. And that perfectly aligns with why it is important to discover and protect your sensitive data and how you can get most out of its capabilities by using Amazon Macie. And for that, using sensitive data discovery mechanism is step one. To create your data discovery jobs, you can choose from two types of data identifiers, which are managed and custom. The managed data identifiers use built-in machine learning and pattern matching techniques. This can detect a large and growing list of data that includes financial, national, or PII, PHI credentials data such as birth date or driver's license identification number or bank account number or even credit card number. But if you potentially have your application specific sensitive data, then you can optionally use custom data identifiers. They can be used to highlight the organizational proprietary data, such as employee ID or internal data classifications. In this, you define a set of criteria using regular expressions to programmatically describe the text patterns, as well as you can supplement the keywords or ignore words that help you to refine the results. Using these two types of data identifiers, Macie analyzes the data in several supported formats, and which includes big data supporting files or compressed or archived files or text or even documents. It's important to understand that Macie analyzes the data from the supported formats only, and it excludes the unsupported ones while running its data discovery jobs. However, it analyzes the data using its deep inspection capabilities depending upon the actual data format rather than just restricting to the file extensions. Which means, let's say if you have an object in your target S3 bucket with .foo extension, then that object will still be analyzed if the actual content in that object belongs to any of the supported format. While creating the sensitive data discovery job, you can choose from a frequency for your data discovery job, and it could be either one-time job or the scheduled job. The one-time job is created once immediately after you finish creating it. Whereas if your target S3 bucket has data coming in at a regular interval, then running the job periodically is recommended. Depending upon how often the data changes occur in your target S3 buckets, you can choose the recurrence frequency to either daily, weekly, or monthly. However, one of the potential challenges you may encounter in this is, what if you're not sure about how often the objects in your target S3 bucket are going to get updated? Then, knowing the right frequency for running your jobs might not be straightforward, and often you might end up in running more or less than what's required. The other challenge could be, how do you ensure that you're optimizing your data discovery runs and only running them if and only after the data changes occur? So, you can address these challenges by adopting the event-driven approach. This will help you to minimize the sensitive data disclosure in your target S3 buckets in a secure as well as cost-optimized manner. So let's understand how this approach is going to work with the design workflow. Whenever there are any updates coming in to your target S3 bucket, SQS queue will be triggered in response to that. And further, it will invoke the Lambda function to start sensitive data discovery job, as well as it will send SNS for notification. And this will result in starting a one-time data discovery job in Amazon Macie. Moving on to see how the architecture for the solution looks like. Whenever you have new objects added to your target S3 bucket, then S3 events notification will trigger the SQS queue. And in the SQS configuration itself, we specify the message delivery delay for your incoming messages. After these messages arrive in the queue, further it will invoke SNS for notification as well as Lambda function to start the data discovery job for Macie. And right after this, your SQS queue will be purged. Finally, in Macie console, you will see a new data discovery job has been created to analyze the newly added data in your respective target S3 bucket. There are two potential questions here. Why do we set the message delivery delay here and also purge the SQS queue right after the Macie data discovery job has been started inside Lambda function? So let's understand that through the implementation details for each of these components. To get started with our solution implementation, it's important to understand what are the prerequisites and what are the overall components involved in our solution. So to start with, SNS and SQS queue are the prerequisites for our solution, after which we can proceed with creating a Lambda function and also S3 events for notifications triggers. Starting with the SNS configuration, you need to create and subscribe to a SNS topic in order to receive the notifications. At the bottom of the screenshot here, I do have 2 subscriptions for this particular SNS topic. Then, creating an SQS queue is our second prerequisite, and it has 3 main steps involved in it. So let's understand what each of those are. So the first one I have in here is the SQS access policy snippet, in which you need to specify the permissions to allow SQS to be able to messages to the queue and also to the SNS subscription. You will be able to specify the SNS ARN here right after you subscribe to it. In the next one, the top screenshot I have here is for SNS association for the SNS topic that we just created to our SQS queue. And the bottom screenshot is for associating Lambda function to our SQS queue. I'll be going over this Lambda function in about next couple of minutes. Coming back to SQS, this is the SQS summary details where we specify the delivery delay of the messages to 15 minutes. So with this configuration, whenever any updates are coming into your target S3 buckets, then in response SQS message will be generated. But that triggered message will be available in the queue only after 15 minutes. As soon as the message actually arrives in the queue, further invocations for SNS and Lambda will take place. Again, all of you might be wondering, why do I set this delay here? So, if you look at our architecture diagram again, then every time a new object is added in your target S3 bucket, then finally in turn, a new Macie job will be created. Now think of a situation where your target S3 bucket objects are getting updated about thousands of times in just a matter of few minutes. Sounds like a scary thought on seeing storm of Macie jobs, right? Indeed, it is. Hence, we are setting the message delivery delay to 15 minutes to help absorb the invocations for SNS and Lambda, and it will also further help to absorb the Macie job invocations as well. Now, moving on with our next part of the configuration, which is Lambda function. It's the same function that I had associated with the SQS queue earlier, and now I'm gonna go over its details. So, this is my Lambda function screenshot that is using Python 3.7, and it's the heart of our solution cookbook. There are three functionalities involved in the Lambda function. So let's get into details of each of them. In the first one, here we are generating a random string and appending it with the specified job name, since every time a new job is created in Macie, the job name needs to be unique. Then, by using current timestamp, I am parsing through 15 minutes back. Why am I doing so? Well, that's useful when we create the data discovery job and specify the parse timestamp in the scoping option. This enables to analyze the only newly added objects only, as we are excluding the objects that were not modified until last 15 minutes. You can also further tweak this timestamp parameter on your end as desired. And the last functionality in the Lambda function is to purge the SQS queue. Again, obvious question, why? So, going back to our architecture diagram again, SQS message delivery delay will help us to control the timestamp of the message arrival. But if there are any consecutive updates coming into your target S3 buckets, then that's still going to trigger the consecutive Lambda functions and in turn consecutive Macie jobs as well. And that is prevented with the SQS purge queue. Inside our Lambda function, right after the Macie job is created, the purge queue clears all the existing as well as the pending messages in the queue that are generated but yet to be appear in the queue. Diving deeper into the event timelines for the event-driven approach, if you have the first update coming into your target S3 bucket at the 0th hour, then in response, SQS will have the message available in the queue after 15 minutes. Then this will trigger the Lambda function where the sensitive data discovery job will be created, and right after this, SQS queue will be purged, and this will happen approximately after 16th minute of the same hour. And during this time, if there are any new updates coming into your target S3 bucket, then all of them would be covered by the last 15 minutes exclude criteria of your data discovery jobs. And everything will be absorbed into one data discovery job only. So allowing few movements for these operations to propagate and also knowing the pricing for each of these components is important here. Hence, understanding the suitable patterns and anti-patterns for this solution is crucial for you to make the right choice of data discovery type for the right workloads. I'll be discussing these patterns and anti-patterns towards the end of the session, so stay tuned on that. Moving on, S3 events is the last and the simplest component of our configuration. Here you specify the events that you would like S3 events to monitor and then associate the respective SQS queue that we created earlier for the notification purposes upon occurrence of the respective events. After completing all of these steps, at this point, your fully working solution will be in place. And now on a higher level, let's see what are the prime benefits we can achieve with this. One-time or scheduled approach provides built-in mechanism that helps you to run jobs immediately or on a fixed recurrence pattern, whereas the event-driven approach provides you granular control over how you're going to analyze your data discovery jobs in response to updates in the target S3 buckets. This is an end-to-end, fully automated solution that removes any manual intervention and having you to predict the object update pattern in your buckets. It also helps you to save cost by efficiently analyzing the data if and only after the actual data changes occur. Things you learned until this point will help you to operationalize Macie efficiently. And now is the time to get the real look and feel of the solution through demo. On my terminal here, I'm listing the objects that I have in my target S3 bucket. And for that, I'm using the list objects API. So I hit enter and I see that I have two files in my target S3 bucket, which are mydata1.txt and mydata2.txt. Here we also see the last modified date parameter, which I had also specified in the Lambda function. And the timestamp that we see here is in UTC. Now from here, I'll go ahead and upload the updated mydata1.txt file in the same S3 bucket where I specify the object key as well as body. And I'm using the put object API call over here. So I hit enter and my call is successful. So if I go back and list the objects again using the same list objects API, then if we look at the timestamp here, then we see the last modified date for mydata1.txt file has been changed to the current timestamp in UTC, whereas the other one remains unchanged. So from here, let's move on and referring back to our architecture here. So just now we uploaded a new object in my target S3 bucket, and this will further trigger SQS and this will invoke the SNS and Lambda function from there. So let's understand each of these components configuration from the console here. So this is my S3 bucket where I do have two files and one of which we uploaded just now. So from here, if I navigate to the properties section and scroll down, then this is the S3 events notification which will trigger the SQS queue upon create objects and restore completion events. From here, the next component we have is going to the SQS queue. So this is the SQS queue that is associated with the S3 events that we saw earlier. And in the detail section here, we specify the delivery delay for messages to 15 minutes. However, for current demo purposes, I have configured it to 1 minute. And scrolling down from here, I have associated the SNS topic as well as Lambda function. So let's take a look at those. First, I'll go to the SNS topic that is associated with my SQS queue. And this is where we see the SQS as one of the subscription. And the next one we have is the Lambda function with Python 3.7. And this is the function that we had seen earlier. So by now, our SNS notification and the Lambda function should have been triggered in response to the object upload operation in my target S3 bucket. And in order to confirm this Lambda function invocation, we will check the CloudWatch logs where the Lambda function metrics are reported. So this is my CloudWatch log group for the respective Lambda function, and we do see several CloudWatch log groups here. So from here, if I go and hit refresh, then we see that a new log stream has been added with the current timestamp. If we go ahead and click on view details for it, then since I'm printing my responses inside my Lambda function, we do see two HTTP 200 OK status codes here, and they belong to successful Macie create job operation as well as SQS purge queue operation. And finally, this confirms a successful Lambda invocation for us. So immediately after this, if we move on to the Macie console dashboard from the jobs section, and if we hit refresh here, then we do see a new job has been started just a couple of minutes back. By clicking on the job, on the right hand side is the result summary where we can see the exclude condition that we had specified for analyzing the objects that had been modified in last 15 minutes only. The timestamp that we see here is in UTC. So this particular job will exclude all the other objects that were modified prior to last 15 minutes. And as per this condition, in my bucket, only mydata1.txt file will be analyzed and generate findings if at all it contains any sensitive data. The other file that I had in my target S3 bucket will remain unchanged. So with that, it completes the demo for the event-driven solution. And now I'm gonna spend next few minutes to speak about Macie best practices. We do have top 8 recommendations that will help you to get started and know all the things for starting with your sensitive data discovery jobs. So let's briefly understand what each of those are. We encourage our customers to configure the detailed data discovery results in Macie as a first step. This helps to detect the sensitive data exact location in your target S3 buckets, which further helps to narrow down the data exposure search and also helps to maintain the privacy better. Then, if you have any encrypted objects inside your target S3 buckets, then Macie's ability to analyze those objects depends on what type of encryption has been used for those objects. So it's very much important to understand what data Macie can and cannot analyze. So first of all, Macie cannot analyze the client-side encryption and customer-provided server-side encryption. On the other hand, Macie can analyze the Amazon S3 managed and KMS AWS managed encryption with service-linked role for Macie. And lastly, Macie can analyze KMS customer managed encryption conditionally only if you provide permission to use the key. The next one we have in here is scoping jobs with the frequency and include exclude objects criteria that I discussed earlier, and this will help you to optimize your data discovery cost effectively. Speaking of cost, when you create a one-time data discovery job in Macie, then it calculates and displays that particular job's estimated cost. And we do encourage customers to leverage this cost to understand what would be their estimated incurred charges. To support integration with other applications and AWS services, Macie automatically publishes the policy as well as sensitive data findings to Amazon EventBridge in the form of events. We do encourage to leverage these integration capabilities to optimize how you decide to act on your findings and to improve overall security posture. On a higher level, use cases wise, meeting the security requirements for your organizations is possible by using advanced scoping options in MESI. Further, you can extend the sensitive data discovery scope for MESI beyond S3. So you can use it for, let's say, Amazon RDS or Amazon Aurora snapshots by exporting that data to S3. And you can also extend the security assessment beyond AWS native data sources, especially during data migration, by setting up S3 as a temporarily staging area for the data analysis of your on-premises data. MESI has a monthly quota for the volume of sensitive data discovery that helps you to cap and manage total spend in your account. In order to run uninterrupted data discovery jobs, we recommend to evaluate how much volume of data you are going to run through MESI, and also, if at all needed, you can increase this quota by using either self-service options or by contacting AWS support. And the last one we have in here is MESI integrates with AWS CloudTrail that captures all the APIs for MESI. And this includes action taken by any user, role, or other AWS services. And this helps greatly during investigation of incidents. In last around 27 minutes, I walked you through several key functionalities, architecture, and solution demo. I also covered some of the critical considerations that you need to think through in your data discovery optimization. So, putting everything together, if there is anything at the least you should take away from today's session, then I would say it's sensitive data discovery in a nutshell. One-time, scheduled, and event-driven are three approaches using which you can perform the data discovery for your sensitive data. As there is not a single size that fits all, there is not a straightforward way of doing analysis by simply choosing one option over the other. At its core, it's truly based on what your data nature is and what your use cases are, and from there, work backwards on having suitable patterns as well as anti-patterns into the consideration. So, speaking of one-time discovery, it is mainly suitable for historical data analysis. The scheduled discovery, on the other hand, is suitable for recurring updates that are happening in your target S3 bucket. For the event-driven approach, as we saw earlier, it's mainly suitable if you cannot predict the frequency of the data updates. In terms of key features, with one time, you can leverage the include-exclude object criteria. And in addition to that, you can optionally specify to classify the newly added objects only in case of scheduled discovery. And while the event-driven inherits all the key features of the one-time approach, it's a fully automated cost-optimized approach if used for right type of workloads. So speaking of anti-patterns, one-time discovery is not suitable for the ongoing data analysis. If you have any critical updates coming into your target S3 buckets that cannot withstand any potential data exposure, then using scheduled discovery will not be suitable for this particular type. And lastly, if you have any updates coming in that belongs to non-critical workloads, or if they are coming in too frequently, such as S3 bucket for streaming applications, then in that case, event-driven approach would not be a right choice for that. Hence, choosing the right data discovery approach for the right workloads will help you to strengthen your overall data protection mechanism in a secure, cost-optimized, and fully automated way. And with that, it's a wrap for this session. I thank everyone for taking time watching this, and I do request to complete the session survey as well. So thanks again and wish you all a great journey in securing your data with AWS.